Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 23 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1262, greatest sum divisible by 3. So in this problem we have given an integer array nums and we have to return the maximum possible sum of elements of the array such that it is divisible by 3, right? So problem statement is very easy, right? So here if you see example number 1, right? So here if you pick 3, 6, 1 and 8, so you are going to get total sum equal to 18, right? And this 18 is completely divisible by 3 because you see when I calculate the modulus is 0, right? Remainder is 0, right? Okay, so there are many possibilities, right? 18. So here if you see, right, like to reach to this 18, right, for every particular number I have some options, right? I have two options actually. I can skip this 3 or I can take this 3, right? Right, so that simply hints towards the recursion, right? So I have two options for every number, whether I want to include it or whether I want to exclude it, right? And based on that I will also keep track of the max sum, right, once I iterate over all the elements, right? And if the sum is completely divided by 3, so I will store this number somewhere, right? Because here if you see, if I pick this 3 6 9 9 plus 5 14 plus 1 15, so 15 also divisible by 3, right? So we will see many numbers which will be completely divisible by 3, right? But we have to keep track of the max number as well, right? So for that also I need to create some variable, right, to store the max number, right? So let's see first approach that comes to my mind here. Okay, let's take this example only, 36518, right? So let's say I have this number 3 6 5 1 and 8. Okay, like this I have number. So initially I have something like this. Initially my I is here, so I am saying that we have two options right here. So whether I want to take this current number 3 or not. So every time, right, in the next stage my I is going to move further, that is fixed, right? Here also my I is going to move further, right, here. But here this side I am saying that, let's say this is skip a part where I'm skipping this, and let's say here this is nothing but take part where I'm taking this current 3, right? So if I am taking this 3, right, if I'm taking this 3, so my sum will be 3 as of now. Sum is equal to 3, right? This is my sum. Okay, so same way here also, right? Here also I have two options, right? Next time this is my I, right? So I have again two options, skip or take. Here also I have two options, skip or take, right? This is nothing but, let's say, skip, and this is nothing but take. So if I'm taking it, right, 3 6 5 1 8, so my I is always moving forward, right? And if I'm taking it, right, so my sum is going to become 6, right? Sum is going to become 6, right? Now same way here also I have two options, right? If I want to skip it and if I want to take it. So let's say I'm taking it, right, 3 6 5 1 8. So here my I is going to move here, and if I'm taking it, so my sum is going to become here, if you notice, 3 6 9 9 plus 5 14. Okay, 14 is the sum. All right, again I have two options here, right? So I'm not solving the complete tree right here you can try to solve it by yourself. Okay, tree will be very big, right? So here again, let's say you have two options, skip or take. Okay, so let's say this time you skip it. So if you skip it, your sum is going to remain 14 only, right? And your I is going to move here, right? This is what is happening. Now let's say you plan to 3 6 5. Okay, so now let's say here uh, let's say you plan to skip it here, and let's say you plan to take it here. Okay, so let's say if you skip it, so 36518 I goes out of mode, and sum is 14, but this 14 is not divisible by 3, right? So definitely from this side you are not going to return any sum, right, as of now, right, if in this tree. Okay, so let's say now instead of 3 6 5, okay, here for 5 also, right, we have two options, skip, take. So I take it, right? So now let's say I skip it. Okay, so now let's say I skip it, so I'm using some other pen now. Okay, so if I skip it, so then I will get something like this, 36518. My I is going to move further only, and sum is going to remain 6 only. Okay, 6, right, if I skip 5. Right, now again here also I have two options, skip and take. Okay, so now here uh 1 second, here 3 I'm taking, right, after that I'm taking 6 now. So here why I'm writing 6, I should write 9 here, right? I should write 9, sum 3 plus 6 is 9. Okay, so let's correct this. So this is going to become 9. Okay, and here if I'm taking 5, 9 plus 5 14, so here I'm writing correct only. All right, so here also we are taking correct only, 6 plus 5 11 13 14 12 13 14. Okay, correct, yeah, here correct. Okay, so here only there was a mistake. Nice. So let's fix this also now. So here it is 9 only, right, if even if we skip 5 now. Okay, now after that I here. Okay, so now let's say I take it, I take this. All right, so next time my sum is going to become 10, and next time I am going to become like this, my eye is going to reach here. Done. Okay, so here also I have two options again, skip and take. So let's say I take it, so 36518 I goes out of bound, and here if I'm taking it, then my sum is going to become 18. But here if you see, 18 is completely divisible by 3, right? So definitely from this tree, right, when my I goes out of bound, so that simply means I have checked all the numbers, right, with options, skip or take. My I goes out of bound, and I'm getting some 18 from here, right, this side. So 18 is the sum. So 18 is the sum that is going from this take state, and from this skip state there may be some other value I'm going to get. So I have to keep only best value, and best value is always going to come if that value is divisible by 3 completely. Okay, otherwise I will just return the minimum value, right? So we have to take the best value, right? Always skip and take. This is what I'm doing, right? So that is the plan actually. That is how I plan to solve this problem. Okay, so also if you see, if I divide any number with 3, right, 1 2 3 4 5 6 7 8 9. Okay, if I divide any number with 3 here, right, so I'm going to get the remainder as 1 here, remainder as 2, remainder as 0, remainder is 1. Okay, 4 divided by 3, 5 divided by 3, remainder is 2, 6 divided by 3, remainder is 0, 7 divided by 3, remainder is 1, 8 divided by 3, remainder is 2, 9 divided by 3, remainder is 0. So always if you see, I will only get 1 2 and 0 1 2 0 0 1 2, right? Only these values are possible, right? So I can do one thing now. I can do one thing here, right? So here this side 18. Okay, so let me show it while writing the code, but let's first write the simple code, skip and take. Okay, so I'm going to write very simple thing in the code, nothing complex, right? So this is your nums, right? So here first just calculate the length. We can calculate, right? So let's calculate the length. We will use this n variable also. Int n is equal to nums dot length, right? And here let's say I create one variable result, and here I'm just going to call one helper method, and this helper method I am passing the starting index, I am passing the nums value, let's say, and after that let's say I'm passing 0. 0 is nothing but the current sum, right? Current sum, let's say. Okay, and here, from here I'm just simply going to return math.max value, right? And here whatever the max between this 0 and the result. So this helper method actually is going to help me find the max number, right? So I'm going to store that number here in the result, right? But if there is no number which is completed user by 3, right? So in that case I will just return something, some minimum number, something like that. Okay, so this is the plan actually, right? So here let's write the code for this helper method. Okay, so private, we may need a memoization as well. Okay, but I will explain that further. Okay, so here helper method, so here I told you just pass I value, and here just pass the nums value, right? And here just pass the sum value, some mode you can do. Okay, let's say some mode is the variable name, right? So here if your I reaches to the end, right? If I is equal to nums dot length, so this is base case, right? So in base case what you need to do, you have to return what? So from here I will just check na, I will check few things, right? Okay, so let me write it also later on. Okay, let's leave it. So here let me show you two options that we have. One is when I'm taking the current number, so int cur is equal to nums of I, right? This is what we are doing. And when we are going to take this, right? When we are going to take this, so what I'm saying, when I'm taking this, so in that case I'm going to call this same helper method, right? I'm going to call this same helper method, and now in this my I is going to move further, right? My I is going to move further, and here my nums, right, array will be remain same only, and here my this sum mode, right, this value. So if I'm taking it now, so this value will be updated, right? This value will be updated. So this how I'm updating it, so I'm updating it like this now, sum mode plus cur, right? This is how I'm updating it, right? This is what I'm saying. Okay, so this is done. And here if I plan to skip this, so what I'm going to do in that case, so in that case also I'm going to do the same thing, right? I'm going to do the same thing, and here instead of this cur I will just simply write this, right? And I told you that we have to take the best result. So there are two trees, so maybe from take I'm getting the max, and from skip I'm getting the max, right? So I have to store the best result. So for best result I'm just going to write math.max of take comma skip, right? This is the plan actually, right? This is a basic plan, right? This is a basic plan. I need to fix few things further, right? Here all these things I have to fix. Okay, now here I'm saying that we know that all these values are 0, 1 or 2, right? So here if instead of sum, if I just represent it as sum mode, right? So 3 modulus with 3 is 0 only, right? 3 modulus with 3 0 only. Here also 9 modulus with 3, so sum mode will remain 0 only, right? If I do just 9 modulus with 3, right? Okay, so instead of getting a very bigger value, right, it there may be many numbers, right? There may be many numbers here if you see constants, right? So nums dot length is this and nums of I value is this, right? We may get very maximum, right? So instead of calculating keep track of this everywhere, right, I know that a number is computed divisible by 3 if the sum mode remains 0, right? If the sum mode remains 0, right, here sum mode is 0, right? Sum mode is 0 here. Here if you see sum mode is not 0, but it is 14 divided by 3 2, right? So here also sum mode is equal to 2, sum mode is equal to 2. So here when we are getting 18, here somewhere we are getting 18, right? So here, yeah, 18. So here also sum mode is equal to 0. So in the end when my I goes out of mode, so I will check now if my sum mode is equal to 0, that simply means number is computed divisible by 3, right? So what I'm doing here in my code, I'm just checking if my sum mode is equal to 0, right? In that case 0, otherwise integer dot mean value, mean underscore value. So I'm just going to return the mean value, right? So that is why here I'm saying the max, give me the max value, right? 0 and this. So if I get some minimum, so just give me 0, right? That is the plan actually here. Okay, this is done, right? And here every time, right? So this is what we are doing. Sum mode is equal to plus cur, right? So this also we need to take care actually here, right? So new mode, how I'm going to calculate? So new mode, first tell me how I'm going to calculate the new mode. Int new mode. So let's say your sum mode is 0 here. Next time you add 6. So you are adding a number. Then again 6 modulus with 3, 0 plus 6, right? So here you are doing 3 plus 6, 9 modulus with this, right? So here I am taking sum mode every time. So 0. So in 0, if you add 6 and then again take the modulus, you will again get 0 here, right? So for sum mode value. So here this is how you calculate the new mode value, right? So new mode is nothing but you are going to say sum mode, okay, and plus cur, and here modulus with 3, right? This is how you are calculating the new mode. So instead of this, just pass this new mode value, right? This new mode value here, okay, this new mode value. Done, this is done. Okay, now this is done, and here you have to just pass the sum mode. Okay, no issues here. All right, now here one more thing. If in the end, right, this is what you are doing, right? But here if you are taking the number, right, if you are taking the number, right, and here just check one more base condition, right? If the take value, right, if the take value, so you are going to solve take method here, right? But if in the end, when you completely solve this take, right, this take part, and in the end if you see that your take method is returning this integer dot mean value, right? So if it is not returning this integer dot mean value, let's say in the end, right, if this take method take side, right, two parts, right? So if in the end your take is not returning this, right, then in that case what you have to do, in the take you have to add the cur value, okay? In the take you have to add the cur value, right, if take is not returning. This is what we need to do. Okay, so let me prove this also. So let's say you have 3 and 6, right? 3 and 6. Okay, so just this, okay, just this part. All right, so initially your I is here, right? So let's say you plan to skip it and you plan to take it. So if you skip it 3 6, okay, here I, and if you take it 3 6 and I is here, right? Now as per your code, as per this current code, your current is 3, current is 3, right? Current is 3, and new mode is equal to 3 plus this new mode is 0, right? 3 plus previous sub mode is 0 in the starting, right? So it is 0 again. So in the this you are passing this, right? And take value, so take value, right? Take value, take is nothing but helper of I plus 1, right? I plus 1 nums of new mode, right? So in this take what you are passing, in this take you are passing your new index I plus 1, the nums array you are passing, and new mode is nothing but just add 3 na, 0 plus 3 modulus with 0 0. This is what you are passing, right? So now in this again you see, next time your I is here, your I is here, right? It is not end, it is not end yet. Now cur is equal to nums of I, cur is equal to nums of I, that is nothing but this time it is 6, right? So if you plan to take it again, you are taking it first, right? New mode is going to be again 0, and if you take it, so now next time take is equal to I plus 1, again you do nums, and this is going to again become 0 only, right? All right, so now here if you see, your 3 6 and I reaches out of bound, right? This is what you are calling here. Okay, so now again you reach here, right? You reach this line, you reach this line. Again you are calling this helper, right? This is how recursion works. Now I becomes nums dot length, right? Now I becomes nums dot length, right? Now in this case, sum mode, if you see the sum mode value here, new mode value, it is 0. So if it is 0, so you are going to pass 0, right? And here you are passing 0. Okay, you are passing 0, you are returning 0. Actually you are returning 0 from here, right? So I is reaching out of bound, right? So you are returning 0 from here. Okay, done. You are returning 0. Okay, so if you are returning 0, you are doing the backtracking here actually, right? You are doing backtracking here, right? So now if you are doing backtracking here, so in this part you have to solve now. So if you see from previous part, we are, our take value is equal to 0, it is not equal to this. So take, in the take you are adding 6, so you are adding 6 here in the take, right? In the take you are adding 6. Okay, now again from this part again you have to do the backtrack. So again, uh, again you have to add what, 3, so you are going to add 9, right? So this is how your take part is going to execute, right? So whenever take is not equal to integer dot min value in the end, so we are backtracking, right? And in the end I am taking the cur value, I am adding the cur value in the take. Okay, skip is very simple, right? This is actually our plan, right? Okay, so now here again, here this sum mode is actually very helpful. Reason is, now we are not going to get sum like this, first 3 then 12 then 18 24. We are using sum mode, right? And in sum mode only 3 values we are seeing, 0 1 2, right? Only 3 values we are seeing. So see, so see here, so this is the example, right? So there may be some repetitive work, right? Maybe when I am here, right, when my eye is here, and I know that some mode at this position is this, right? And I have already solved this part, and let's say this is a case which comes here in this side, and the same case which comes here also, right? So in this side if I already solved this case, so here I can simply use a memoization. I can simply return that part, right? So memoization is simply this thing, right? So if I have already solved that part in the past, just directly get the result, don't need to solve this tree further, right? So what I'm saying, if I have already solved this subtree, and if again I'm trying to solve this somewhere here, right? So in that case we can easily skip if we know that where we are, which index we have, and what is the mode value, what is the sum mode value. So if you see in your this code, only two values are changing, right? Only two values are changing, one is the index and one is the sum mode value, right? Only these values are changing, and sum mode value we fixed it to only 3, right? Only 3 values can be there, 0 1 and 2 here, right? And index is nothing but the all the values, right? What is the total size. So based on this I will create one memoization array, right? So what I'm trying to do now here, so first thing here I'm going to create one memoization array, int memo is equal to new int, and here I told you n, and here I told you 3, right? So now what we do, we just fill all the values with minimum value, right? So here int, let's say a is equal to 0, a is less than n, and here a plus plus. Okay, and arrays dot fill, and here memo of a, okay, this value I'm just going to fill with integer dot min underscore value, right? So this is how I'm going to fill the values. So all the values I'm filling, right? All the rows one by one, arrays dot fill all the rows, right? So this is a 2D array I'm creating, right? And in the result now I will just simply pass this memo, right? So that I can easily get the result of pre-calculated trees, right? So I am passing memo. So if I am passing memo here, so definitely I have to add memos here, right? And same way in the method also I have to pass the memo, and here in the skip also I have to pass the memo, right? And here one thing we need to do here, I will just check now here first whatever the result we are getting, right? So I have to store that result somewhere, right? So cur I'm taking this, new mode is taking this, okay, all that stuff. So here this value, right? So I will just store this value now, like this is what we are doing, right? So I will store this value in the memo, right? Best value I will store. So memo result at this, when we are at this I index and we have this sum mode, so and during that time the result for the further calculated tree was this thing, right? This is how I'm going to update the value, right? And here I can now simply just return this part, okay, that's it. So this is how I'm planning to do this, right? And here I will just add one check that if the memo of I sum mode is not equal to what, integer dot min value, right? So this is how we have stored the values, right? So that simply means that we have already pre-calculated this somewhere, right, in the past. So in that case I'm just going to return this memo of I sum mode, that's it. Okay, so this is the plan, right? So now let's see if we are missing anything. Let's run it. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So this is the approach one to solve this problem. Using DP also you can solve, right? So this is nothing but a recursion plus memoization approach, right? So simple skip and take we have to do, right? So, and see, only 25 lines of code, that's it. Okay, let me show you other approach as well, right? DP approach. So let's take this same example, 36518. Okay, approach number 2. Let me use this pen. Approach 2. Okay, so here also we have 3, 6, 5, 1 and 8. So now you know that we are making sure that it is divisible by 3, right? So we are getting the remainders like this, 0, 1 and 2, right? So see here, uh, we are going to get 3 plus 6, we are going to get 9. Okay, and we may also get something like this, na? 3, 1. So after that we get 5, then also it is 9. Same way we can also get like this, na? 2 plus 7 and then it is 9, right? So all the remainders are actually beneficial, right? So in this remainder, whenever let's say until here I reach, I get the remainder 2. So maybe somewhere in the future I will get what, I will get some value like 7 and I will get overall result as 9. So all these remainders are useful, right? Because in all these remainders if I add some more value, right, like in 3 if I add 6 only I will get 0, but here until here 4 we have, so in this 4 I need to add 5 so that I get a 5 9 9, right? So I'm just saying that all these remainders are helpful, right? So what I will do, I'm going to create one dp, right, one dp array, right? In dp array I'm going to store the values, right? I'm going to store the best values, best values of sum in which I have remainder is equal to 0, in which I have remainder is equal to 1, in which I have remainder is equal to 2. This is my plan. Okay, so let's see. Okay, so first time you are here, okay, this is the current number, right? And let's say initially your dp is like this, 0, and here minus infinity, right? So here what do we need to do? If you see, we have to return, given an integer array nums, we have to return the maximum possible sum of elements of the array such that it is divisible by 3, right? And if it's not, then we have to return 0, right? So only divisible by 3 matters, right? Only divisible by 3 matters, and if divisible by 3 matters, that simply means remainder should be 0, right? But why I am taking remainder is equal to 1 and remainder is equal to 2, so that I've explained here. Because even if I have a remainder until 2 here, but somewhere in the future if I get 7, so I will again get 9, which is completely divisible by 3, and again going to get remainder 0, right? So we have to calculate the best value of sum everywhere, right? Because in the best value of sum for all these, RAM is equal to 0, RAM is equal to 1, RAM is equal to 2, we may get RAM is equal to 0 in the future, right? So this is the plan. Okay, right? And here I'm taking 0, and here I'm taking minus infinity initially, right? Okay, so now here for 3, first this 3. Okay, so here if you see this 3 value, right, this is the current value, right? So in my dp, right, dp of let's say if my remainder is equal to 0 first, so dp of 0, right? So dp of 0 right now, initially if you see, this is my dp of 0, right? This index is not equal to integer dot mean value, is not equal to integer dot main underscore value. For this one, code is going to be very small. Okay, so now in that case, so here I'm saying if dp of 0 is not equal to this, then in that case your new sum is equal to, new sum is equal to, add this, just add this value, so you are going to get what I'm saying, dp of r plus num, and we have to check for r is equal to 0, 1 and 2. Right now I'm checking for r is equal to 0, so that is why dp of 0, right? So this is nothing but r value. Okay, so this is what you need to do, dp of r plus 0, dp of 0 0 plus num 3, so 3 is a new sum you are going to get, right? So for this new sum, right, so what is a new remainder that you are going to get if you take this new sum? So that simply means new sum modulus with 3, so that simply you are going to get again 0, you are getting again 0, right? So if you are getting 0, so let's say this is one temp is nothing but it's like a dp only, I just cloned it. Okay, so temp, and add new r, I'm just going to add the max value, math.max of temp of new r, math.max of temp of new r value, and here I'm just going to pass new sum value. Okay, so just don't worry about this code. Okay, I will show you what is happening. All right, so now just for see first case. Okay, so this is the new sum you are going to get is 3, so 3 modulus with 3 is 0. So now you are updating temp of 0 only, with what, with the max value. Temp of new or previous value is 0, new sum is 3, so I'm just going to update is 3 here. So now if I am updating it 3, right, if I am updating it with 3, so that simply means that 3 is the best sum. Until here 3 is the best sum, and with this 3 as the best sum, I am getting the remainder is equal to 0, right? And here I am not getting remainder is equal to 1, so it is still infinity, minus infinity, it's still minus infinity. Okay, that is the meaning, that is what I want, right? Now next time my eye moves here, so again if you see now, again if you see, so 3 plus 6 is a 9, so 9 is the best sum, right? So here let me write it like this. So 9 is the best sum until here, right, with which I'm getting the remainder is equal to 0, and still I don't see remainder is equal to 1 and remainder is equal to 2, right? So this is the plan. All right, now after that, when my eye reaches here, now there is going to be some twist. Okay, so again first we have to check for r is equal to 0, right? So dp of r, it is still not equal to this, right? It is not equal to this, right? So new sum is going to be 9 plus 5, 14. 9 plus 5 is 14. Okay, and 14 is a new sum I'm getting. Okay, new remainder I'm going to get 2, right? New remainder I'm going to get 2, and my temp of 2, now this time temp of 2 is getting updated, right, with the math.max of temp of 2 is nothing but infinity minus infinity, and new sum is nothing but 14, right? So now it makes sense, right? So 14, if you do 14 modulus with 3, you are going to get 2 remainder, right? So 14 is the best value you have seen for the remainder is equal to 2, right? If you just ignore this code and just see this, how I'm feeling. So 14 is the best value with which I'm going to get a remainder is equal to 2, right? Done. Now next time, let's say my eye moves here, right? My eye moves here. So now I'm going to get what when my eye moves here. So again, there is going to be a twist, right? So now here, here, here. Okay. All right. So here, if you see, for okay, for 14, right, when I get this value, so only this was done, right? And then one also I need to check, two also I need to check, 14. Okay, 14 also it's done, right? New sum is equal to this, right? And yeah, that's it. Okay, so now let's say your eye is here. Okay, your eye is here. Again you have to check for all this ram 0, ram 1 and ram 2. Okay, all these are values one by one, right? So this, at this we have 9, right? At this we have 9. So in this 9, if I add 10, if I add 1, okay, so I'm going to get 9 plus 1 is equal to 10. So 10 means remainder is equal to 1, so at temp of 1, so at temp of 1 I'm going to place here what I'm going to place here 10, right? Because 10 is the best number I have seen as of now, in which I am going to get a remainder is equal to 1, right? Is there any number I have seen in the past with which I'm going to get a remainder is equal to 1? No. So 10 is the best, right? Same way, you have to actually iterate over all this, right? So dp of 1, so this was infinity only last time, minus infinity only, right? Last time. But this time I am updating what dp, but I am updating in the temp. I'm updating it in the temp, right? Not in the dp directly. Here I'm showing it in dp, but I'm updating in temp, right? And then I'm making the copy of this temp to dp, right? So, and last time here if you see 14, so in this 14 also we may add this 1, right? So I'm going to get 15. 14 plus 1, 15. 15 remainder with the 3 is 0, right? So 15 is the best answer here as of now, right? So 15, 10 and 14. Okay, done here. Now next time your eye moves here. So again, 15 plus 8. 15 plus 8 is nothing but this is actually very simple, right? 8, 5, 9, 10, 11, 12, 13, right? 23, right? 8, 9, 10, 11, 12, 13, right? 23. 23 modulus with 3 is nothing but 2, right? So here I'm going to store 23. 23 is the best result, right? Same way here in this 10 plus 18. 10 plus 18 is 18. 18 you are going to get, so 18 is the best, right? 18 is the best. Okay, with which I'm going to get the remainder 0, right? So here also last time it was 14. Okay, no, don't see this 23 value is updating in temp only, right? But here I'm writing in on top of dp just to show you, but actually we are updating in temp first, right? So 14, last time 14. 14 plus 8, if I do 14 plus 8, that is 22. So 22 is the best value, right, with which I'm going to get the remainder is equal to 1, right? So that's it. This is what we need to do, right? So approach to is actually very simple. Okay, very simple. So let me just revert it. So here I told you that I have to take one dp array, right? And here new int, okay, and here I will just pass what, so 0 I'm going to pass, and here I'm going to pass integer dot min underscore value, and here I'm going to pass integer dot min underscore value. Okay, I'm passing these things, right? Now here you have to just iterate over all the numbers, right? For int num in nums, right? So you have to iterate over all the nums one by one, right? And inside this I'm taking one temp, right? Note it, I am creating one temp array, right? And I'm just cloning it from dp. So dp.clone, it is just act like dp only, right? Same array as dp. This is done. Now I have to check all the values of r inside this. So int r is equal to 0, and I know that r value is less than 3, and here I know r plus plus. Okay, now here if dp of r I'm checking. Dp of r, I'm not checking temp of r, I'm checking dp of r, right? This temp I'm going to update, but I'm checking dp of r, right? So dp of r, if it is not equal to integer dot mean underscore value, right? Mean underscore value, right? So reason we are taking this r is equal to 0, right? This infinity minus infinity minus infinity, because initially your sum is 0 only, right? And 0 is completely divisible by 3, right? So that is why I'm taking 0 is the max number with which I will get 0, right? Initially I'm taking 0, right? I don't know any other numbers, right? So initially I just writing 0, right? Okay, so this is done, right? Now here, how I'm calculating the new sum value? Int new sum value is nothing but dp of r. I'm doing dp of r, no temp of r, dp of r plus num. Okay, and how I'm calculating the new r? New r, I'm calculating it as new sum modulus with 3. Okay, this is how I'm doing this. And here I'm operating temp, not dp. Just make sure, not dp, only temp. Okay, so here I'm operating it as math dot max of what? Temp. And here new r, and here I am updating new sum. That's it. Okay, so once all this is done, once all this thing is done, right, for all the r values I have updated my temp, right? Now I'm just going to make my dp equal to temp only, right? This is the plan. And in the end you just want to return what? Dp of 0. That's it. This is your code. Very simple, right? Only 17 lines of code, right? Now let's run it. So there is some issue, right? So let's fix it and let's run it again. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And what is going to be time complexity? Time complexity is going to be of n. The reason is we are just iterating over all the elements in number one time, right? And after that I'm just iterating it over three, just 2 3 values, right? Okay, that's it. So very easy, right? And here I'm just cloning it. Okay, this dp, and this dp size is also very small, only 3 values are there, right? So this is also going to be just constant only of 3, and this is of n. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.